Hey Georgia, if you were going to restart learning how to code and get into bioinformatics, how would you do it in 2023? Do you know what? That's a great question. And it's a question I got asked this week. So I figured let's document this and let's crack on to it. If you're new here, my name's Georgia. This is Genomics with Georgia, and I am a genomic data scientist living in Cambridge in the UK. I make loads of content about how to transition from wet lab biology into dry lab biology. Let's get into today's video. Oh, guys, I'm back and I'm better and I'm with beans. I'm not depressed anymore. So I figured it's time to start filming some more content. If I was going to learn this all again from zero to, not 100, but zero to where I am today, what would I do differently? Where would I start? What kind of things would I be doing now I've been able to reflect on what somebody showed me yesterday was a 3-year journey to get to this place now. So number one, if I was going to restart learning how to get into bioinformatics today, first thing, you've got to learn your coding fundamentals. So as always, my 3 recommendations of languages to learn, we've got Python, we've got Bash, and we've got R. So I've learned Python first and no regrets, insert Dappy. No regrets, I would definitely learn Python first. Python is notoriously known as the easiest programming language to learn if you're a massive newbie. There are so many free courses, how to learn it too. I'll link a bunch down below. We've got things like Code Academy, Data Quest, Data Camp. You just type into your Google search engine, learn Python. You're going to have so many resources at your fingertips. Also, shameless plug, another one is with CFG. If you're at uni or wanting to career switch, check out their free courses in my description box. But anyway, Python, learn that first. Second, you need to learn Bash. Bash is the way that we interact with the actual computer, because usually you're like, oh, click, drag, click, drop. So you want to interact with loads of different files. You've got to talk to the computer directly, and Bash is going to allow us to do that. So I spoke about this before. Bash is your best friend, and essentially learn what is a command line, what is a terminal. Once you get familiar with these kind of concepts and actually interacting with the heart of your computer, then you're going to be in a much better place in order to actually have the skills to work with the cool data that we get to work with. And then the third programming language is R. Now, I might be wrong, and it's all down to experience, but I would say from my experience of the job market and talking to people, I would say that R is mainly more academic. Kind of smaller research groups often use R, but I think the field is transitioning into doing more analysis with Python. There are a lot of R packages that are very well designed for bioinformatics tasks, but Python is a more general data analysis tool. We also have a bunch of scientific packages in Python designed for working with genomic data. So I think be familiar with R is my recommendation. Be able to edit a script, be able to understand what the code is doing. But I wouldn't say you need to be proficient in R to be a data scientist. I'd say you need Python or R. And if I was going to opt for one of the two, I'd opt for Python. But just my recommendation, disclaimer, lots of people will disagree with me wildly. So that is that. Here is the second thing I would then do if I was relearning how to code and how to get this job. And this is something I deeply, deeply regret not doing. Once you've got coding skills down, the second thing you want to do is start applying that knowledge to data. So I was lucky enough to do this in an internship. So I was able to learn those coding fundamentals, then do my internship, which I know people have asked for a video on that, so I'll do another video explaining my internship experience with the Genetic Society, which was awesome. But anyway, use those skills you've learned on some real data. Now you might be thinking, Georgia, where am I going to find real data from? I'm not in this field yet. I can't access genomic data. Well, let me tell you, my friends, there is a bunch of resources online that you can go to. You can play around with data. You can use the skills you've learned and apply them. So I keep recommending to the lovely wet lab people that come to talk to me at work, I would suggest getting your teeth into Kaggle. So Kaggle is a really great online resource. I will show it on the screen now. And Kaggle has a ton of data sets ready for you to go and play with. They have competitions where you can compete with your code. But I think I found Kaggle really helpful for actually looking at other people's code and seeing what they've done with the data set. So say there's a analysis technique you want to learn. Sometimes the documentations obviously have how to use them, but Kaggle will have examples of people using those analysis techniques that you're interested on these data sets, and then they will have published that code on the Kaggle website. So I think it's an invaluable resource for you to A, get your hands on some data, B, look at what other people do with that data, and then C, upload your own data in the competitions that Kaggle hosts. So I think this is super key for getting your teeth stuck into actually playing around with this data. So a lot of the data sets on Kaggle obviously are not bioinformatics, but there is a massive section of bioinformatic data on there. I will make sure that's in the description in a link. So once you've got the fundamentals down of data analysis, coding skills, go get your teeth into Kaggle. There are also more and more other data sets online. I'm just vouching for Kaggle because I think it's great. If you want to sponsor me, Kaggle, feel free. But there are other loads of free data resources online, which I will also link below. The key part here, which is the thing I regret the most, is I didn't make a portfolio. And whenever you're learning to code, and if you go to like workshops and classes, they always tell you to make a portfolio. And what did this idiot not do? This idiot did not make a portfolio. Get yourself a GitHub account. And basically what you're going to do is you're going to create your own repository and you're going to start building up your portfolio. So when you apply your coding knowledge to these data sets that you've found, it can be private at this point, doesn't need to be public, but you need to keep generating items for your portfolio to show that you can code. Otherwise, you're here like me saying, hey, I can code, I promise. And then people are like, can I see some evidence of that since you don't have a qualification? And I'll say, I did some Code Academy courses one time and I promise I can do it. And do you know what? Like, sometimes that's not good enough. So biggest mistake I made in my journey was not starting a portfolio. So 100%, as soon as you get to the point where you can actually generate your own code, start a portfolio. Very, very key. At the moment, a lot of job adverts that are being advertised for these kind of roles are specifying that if you don't have the degree in the bioinformatics and the data science, etc., they will accept evidence of your ability with a portfolio. So sometimes your word isn't good enough. Sometimes your recommendations aren't good enough. And you need to have evidence if you don't have the qualification. So basically build your own qualification, right? You don't have a degree in bioinformatics, who cares? Build your own evidence base on GitHub. Then no one can argue that you don't know how to do the requirements of that job. Very important. The next thing you could try and do is apply this knowledge with other people. And what do I mean by that? So instead of, on your own at home, coding away in a dark corner, it's so dark, you're like in the zone, coding all alone. I'd suggest one thing that you could do is to try and integrate coding into your day-to-day life, but kind of like in the tasks that you do already. So say you work with spreadsheets all the time. Can you do that task by importing that spreadsheet into pandas with Python and wrangle it that way? Are there things you can take in your day-to-day life and put coding in them so that every day or whenever you do that said task, you're practicing the skill, you're integrating it into your work. And then when someone says, oh, do you know Python? You'd be like, oh yeah, I use Python for my data wrangling exercises at work. So it's not just a hobby, it's then part of your job, which is a great way again to practice and showcase the utility and the value of what you can do. The next thing I would do if I was restarting all over again is I would be more intentional with the workshops that I went to. So what do I mean by that? What I'm trying to say is when I was attending workshops, when I was learning to code and trying to learn my skill set, I only attended things that fell into my inbox. So if there was an email that went round about something, if my manager had told me about something, you know, then I would go and look at it and apply to go on the workshop. However, there are so many other workshops and courses out there that the people in your close network aren't telling you about, and it's up to you to go and find them. So, did you know most research institutes and universities on their websites have special pages dedicated to courses, to learning, to development? So if you go on these, some of them even have bioinformatics sections. Go on them, check them out, see what's in your local area and see if it's applicable to you. Some of these are free, which is awesome. Thank you so much. Some of these are a small fee, which might be manageable for some. And then other courses are crazy expensive. So only look at those ones if you are super, super rich. But conclusion, look at the local places you can travel to or research institutes you're interested in. Go on their websites, see what courses they've got and see if you can go and do any of them. Some of these courses can be super basic, from like learning how to do Python. Some of them can be really much more sophisticated, like learning image analysis techniques in Python. So there's a massive array of things on offer, and be more intentional with your choices. And finally, the last thing I would do differently if I was relearning this whole journey would be to talk to more people. I found talking to people invaluable, but I must say, from having conversations with people over the past year, I've realised that I didn't speak to as many people when I was trying to learn as I thought I did. So it's really important to have a widest possible view of the genomics, data, bioinformatics landscape. So talk to people in your team if they work in the data space, talk to people at your institute if they're in positions you're interested in, talk to people on LinkedIn if they're in some other company, even across the ocean, that has a really cool job and you're interested. Like, go and talk to them and see what advice they've got. Because my mistake was I only spoke to a few people, to be fair, about getting into this field, and I just missed out on a whole bunch of key information. I mean, first of all, I never learned SQL as like a language. I then got into my job and they were like, oh yeah, you can query SQL, right? And I was like, no. So then I was playing catch up learning SQL so I could like actually handle the data. I think it's so key to talk to people in the field, figure out what they suggest you need, and then you've got more information to like make an informed decision yourself about what's worth investing your time in. Another thing is, I really suggest, if you can and you've got a supportive one, talk to your manager. So your manager might be able to help you in terms of, they might have people to refer you to have a conversation with. They might be able to support you in terms of providing funding to go on courses for development. And they might be able to set you up with schemes at your workplace, things like work shadowing. So talk to your manager if you've got a supportive one and make use of that connection. So guys, that is it. That's a wrap. Thank you so much for joining me on another video, talking about all the mistakes I made on my journey and the things that you can do to be better than me, essentially. I'm Georgia. This has been Genomics with Georgia, and see you on another video. I don't like this. What is this about? All right, bye.